Hello and welcome. My name is Bianca Coop and I will be your host for today. Welcome to today's webinar, part 2 of Design Considerations for High Performance Fleet Telematics. This webinar will be recorded and available on demand for future reference. Please submit your questions using the panel on the right-hand side of your screen throughout today's presentation. The agenda for today is as follows. We will have a speaker's introduction, a summary of the part 1 for design challenges of fleet telematics ecosystem, an overview of embedded planet, epConnected fleet telematics solutions, following with TE connectivity sensors. As we move forward, today's speakers will include Nathan Lee. Nathan Lee is the Senior Manager of the IoT Sales and Business Development for TE Connectivity's Data and Devices Business Unit. Nathan leads the IoT Sales and Business Development. As we move forward, Steve Weers is the Regional Sales Director for Telit. He is responsible for driving sales of complex wireless components throughout the translation of customers' technical and business requirements into successful Internet of Things implementations. We also welcome Matt Hoover. Matt is the CEO at Embedded Planet, whose career has included different elements, including leadership, sales, marketing, and development roles. And lastly, we welcome John Tooley. John Tooley is currently responsible for Global Industrial and IoT Business Development for TE Connectivity's Sensor Business Unit based in Texas. We hope you enjoyed today's presentation, and without further ado, I invite Nathan to continue today's presentation.
Thank you, Bianca. Welcome, everyone, to the part 2 of the Fleet Telematics webinar. As just a quick overview of TE Connectivity. TE Connectivity is one of the largest interconnect companies in the world. At TE Connectivity, we create a safer, connected future in a number of key markets, including transportation, medical, networking, and the IoT market. The fleet telematics typically falls into the transportation and IoT market. As outlined in the first Fleet Telematics webinar, a basic fleet telematics system can be grouped into 5 key parts. The first part here, the data. The data is used in the system. This data can be located, can be the location of the vehicle, the speed of the vehicle, the health of the vehicle, and the data from the sensors located around the vehicle. Sensor data can include temperature, vibration, humidity, CO2 levels, and many more data points. Let's look at the second part of this. The in-vehicle device, normally in the fleet telematics box, sometimes called the black box, is the brains behind the system. It typically collects the data, formats the data, and then sends the data out. This data is normally sent in the third pillar there through the cellular network. This data is also controlled through the cellular network and transmitting the GPS data, etc., using the cellular network. Once the data is sent to the cloud or the secure servers, the fleet telematics software analyzes the data, makes decisions based on the given parameters on the end user, and then also allows any end user around the world to view the data. For example, where's the truck located now? What is the temperature of the refrigeration cooler back in the trailer? What is the CO2 levels, which is important for a lot of fruit and vegetables, etc. So now let's take another look at a fleet telematics box. In this diagram, we look at the basic building blocks of an in-vehicle device, or the black box, for the fleet telematics system. The 2 main components of this system are the main board and the radio board. The main board collects the data, formats the data from the sensor inputs. After the data is collected, the main board makes decisions on when to transmit this data to the cellular network via the radio module. For example, here, Telit does a lot of radio modules, either collecting the data from Bluetooth sensors or sending out the data via the cellular network using one of their devices that we will review later. TE Connectivity offers a number of solutions in this type of design. TE offers the radio signal interconnects, including antennas, RF connectors, RF cables, and also spring fingers that are used often with the connection points between antennas. In terms of power connections, TE Connectivity offers power connectors, battery holders, and also spring fingers. Spring fingers can also be used to transmit power back and forth between devices. Other interconnect items that TE can supply are USB-C connectors, FPC connectors for displays, board-to-board connectors to reduce the size of the design, and TE also offers a variety of SD cards and SIM card holders also available from TE. One device here that we have on the screen here is used by the Embedded Planets Fleet Telematics solution that Matt will review later during this presentation. This is a 2-port GAR antenna from TE Connectivity. This antenna is a perfect solution for an LTE Cat M1 solution and also has a GNSS port included. For more details about this antenna, please visit te.com. Now I would like to hand the presentation over to Steve Weirs from Telit Wireless.
Thank you, Nathan. This is Steve Weirs from Telit, and I'll give you an overview of Telit's products and solutions. I'll talk about the cellular module that's in the telematics solution and the connectivity plan that goes with it. First off, as far as Telit, we have 3 pillars of our business that we focus on. The first is modules. We make a wide variety of modules encompassing cellular, Wi-Fi, Bluetooth, and GNSS receivers. The second pillar is connectivity. Connectivity is a vital component to a cellular connected solution, and Telit offers a wide range of data plans and services that are complementary to a cellular connected solution. And then the third is software and platforms. Telit leverages our software platform for device management, for data management, for the management of the connectivity data plans. So we leverage that to better wrap the modules and connectivity together and bring it all as one cohesive element. Next. So the module that's in the telematics solution, it's Telit's ME910C1. This is a Cat M1 / narrowband combination module, and it's in Telit's 910 family. What that means is we make a broad variety of modules, Cat 4, Cat 1, narrowband only, modules that fit in that footprint, and also allow legacy solutions based on 2G and 3G to be used in that same footprint. The module is a global module, so it has approvals, both regulatory and carrier approvals from around the world. It has a GNSS receiver in it that supports the GNSS constellations, and this receiver can be used concurrently with cellular, so you get the full performance out of the GNSS module. As far as approvals, we do have regulatory approvals from around the world, and Telit works with our customers to get any additional approvals that are required. It is an industrial temp range module, so it's good over the entire industrial temp range. The module supports Telit OneEdge, and the module has at runtime, when it's manufactured, a certificate that's loaded into it to enable connection to Telit's OneEdge device manager server. What this means is there's no provisioning required if you choose to use it this way. When you turn the module on, and it will register on the network, and if you selected this option, you can connect directly to the OneEdge server without the need to load external certificates into the module or the application processor. Application development is provided by AppZone, so we have application space with a dedicated processor on the module if you choose to use that for, say, a hostless implementation. We do have cloud connectors built into the module for connecting to various end platforms. The interfaces, primarily, people would connect to a host system, either USB or UART, but we do provide other interfaces that can be leveraged via AppZone. And then finally, drivers, you can run this module bare metal with a MCU or use Windows, Linux, Android, whatever your choice. Next. For the connectivity, the data plan that's used with the module is Telit's Next data plan. It's a global roaming data plan, and it complements the carriers that we offer home network services with. What this means is, under one contract, one billing structure, you have the total flexibility to pick the carriers you'd like to use, whether you want to run on a home network in North America or you want to run globally. So with one contract, you have complete flexibility for both North American and global deployments. We have the technologies that support multiple SIM cards, as shown on the next slide. So we can provide commercial and industrial form factor SIM cards that plug into a socket. We have the MFF2 form factor, which is solderable. If you want to implement it in a very small package, we support wafer level chip scale packaging. So we have a lot of flexibility on implementing the data plans in your designs. We also support two modes of operation: multi-IMSI, which would allow, a Telit Next global plan along with a North American home network plan on the same SIM card. And we also support the eSIM technology, which allows for remote SIM provisioning from the Telit platform. Next. Now we'll turn it over to Matt Hoover. We'll continue on with the Embedded Planet Fleet solution.
Great, thank you, Steve. Embedded Planet has been helping customers connect their products since 1997. We help customers realize the benefits of IoT by wirelessly connecting sensors so they can turn real-world data into valuable information. We can help customers create the right IoT system and help them solve the software, electronic, mechanical, and system integration challenges to create a world-class IoT solution. We have several targeted IoT solutions, including epConnected Vehicle, which we'll cover today. Using epConnected Vehicle, upfitters and fleet managers can see the OBD2 information as well as items not included in OBD2, like battery system status, custom equipment, vehicle location, driver status, acceleration, and braking. Users can have direct access to all the data coming from epConnected Vehicle, and they can turn that data into valuable information. Embedded Planet can bundle the epConnected Vehicle telematics solution so upfitters and customers can order one part number and receive the epConnected Vehicle system, antennas, cables, cellular connectivity, and software all in one easy-to-use kit. Embedded Planet can also customize the system to meet customer requirements. For the system today, epConnected Vehicle uses OBD2 connection for power and data. We can also integrate epConnected Vehicle into a complete solution based on customer requirements. Our fleet management solution that we're showing today for the webinar is using epConnected Vehicle, TE connectivity antennas, like the 2-port antenna that Nathan discussed, and the TE wireless sensor MU5600. In addition, We are using the components that Steve discussed, including Telit Cellular Module, Telit Connectivity, and Telit OneEdge for device management. epConnected Vehicle can send data directly to the customer's own database or server, and we can also send the data directly to AWS, Azure, or other cloud solution. User dashboards can also be created to show alarms, GPS location, configuration for SMS, text messages, vehicle status, and other information can be configured per customer requirements. Now we'll talk about a couple customer examples. In our first customer application, we supply the complete kit at the left inside the red border to a lawn treatment customer. This customer uses epConnected Vehicle to manage and track their fleet of trucks, which are used to treat lawns. The kit contains epConnected Vehicle, mounting hardware, OBD2 cable plus 2 custom cables, the TE connectivity antenna, and TE's 5600 pressure sensor, Telit SIM, and Telit OneEdge, and the customer's software application. Customer uses the TE 5600 wireless sensor to monitor pressure in the lawn treatment tank. Serial interfaces are also used to connect to the flow control system, which manages and monitors the flow of the lawn treatment application. The customer populates their database with data from epConnected Vehicle so they can analyze their fleet performance and provide their end customers with details regarding each lawn treatment. Fleet maintenance personnel can also receive alerts via SMS text or email regarding truck status and the status of the equipment used during treatment. Our second application, we supply the kit at the left in the red border to a garbage truck manufacturer. This customer uses epConnected Vehicle as a foundation for their SaaS offering for their customers. The kit contains epConnected Vehicle, mounting hardware, TE antenna, TE 5600 pressure sensor, Telit SIM and OneEdge, and the customer's software application. The customer uses the TE 5600 wireless sensor to monitor the hydraulic system on the truck. The customer uses data to populate their SaaS database for fleet analysis and provide their end customers with detailed service information. Fleet maintenance personnel can also receive alerts regarding truck location, truck status, and hydraulic system status. Now we'll take a look inside the epConnected Vehicle system. We use our Agora modem, which includes processing, sensors, Bluetooth connectivity, and the Telit ME910 cellular module. The epConnected Vehicle system is designed to tolerate truck environments and allows 12 volt and 24 volt power options, fault protected I/O, which includes 4 inputs and outputs, and the inputs can be used for status of ignition, transmission, and temperature switches. Outputs allow you to see engine status and turn the engine on and off, turn fans and lights on and off. 2 serial ports are also available for connecting to other devices like battery management systems, hydraulic controls, just general control systems, and other custom devices. Battery backup is also included, and antenna options allow for flexible installation. Finally, internal and external enclosures are also available. One of the key features of the system is Bluetooth connectivity for reading wireless sensors like the TE 5600 pressure sensor, or you can use Bluetooth for system configuration. Inside the epConnected Vehicle module is our Agora modem sensor platform. Agora is a certified modem for AT&T and Verizon, and it uses the Telit ME910 cellular module. Sensors include both a 6 and 9 axis IMU, air quality, temperature, humidity, microphone, and tamper detect. There is also an interface on the module called the Tectonic Edge, which allows you direct access into the processor, the sensors, and the Telit ME910 module. A number of options are available for configuration related to the SIM, antennas, sensors, and population options. epConnected vehicle can be bundled with Telit connectivity for global access to over 600 networks, which Steve covered earlier. Telit and epConnected vehicle also support multiple SIM technologies, which makes it very easy for customers to implement their system. Telit OneEdge provides a significant number of functions to manage the cellular devices. An embedded planet can bundle both Telit OneEdge and SIMs into a complete solution. Now we'll take a look at Telit OneEdge. OneEdge provides several ways to view your devices in your fleet, including geographic, logical, and ICC ID or SIM. In OneEdge, you have access to device management, device organization, data delivery, SIM management, events, data usage, security, and other functions. Now we'll take a look at the connections display. The connections display allows you to see an overview of your devices and allows you to navigate to individual SIMs. And you can see overall fleet data, devices by location, and individual devices sorted by data usage. Now we'll take a look at the individual SIM that we're using for today's webinar. The SIM ending in 2521 is the one we're using for today. The display at the left shows detailed information related to that individual SIM. You can also see the IMEI number for the Telit module. The display on the right shows data usage for this specific SIM. There is also an actions menu that's available for you to perform direct actions on the modem inside Embedded Planet's epConnected vehicle. You can also execute AT commands directly to the Telit ME910 module running on Agora. Also inside OneEdge, you have access to a number of different data methods to move data from epConnected vehicle into the cloud. You'll see those listed under endpoints. On the right, you see the actual JSON packet of data information coming from epConnected vehicle and being pushed into the cloud, into OneEdge, and then into our dashboard, which we'll show next. The dashboard that we're using for today's demo shows map location, VIN, gauges for speed, engine load, fuel level, and coolant temperature, plus a parameter listing at the bottom left, which shows latitude and longitude, and the numerical values for the numbers in the gauges. Note the Bluetooth wireless sensor data from the TE5600 sensor on the right of the dashboard. epConnected vehicle can be used as a Bluetooth sensor gateway to move wireless sensor data from the truck to the customer's database. Fleet managers or support personnel can receive text messages or alerts related to events they want to monitor in the vehicle. In closing, Embedded Planet can provide customers with a complete production solution, which includes epConnected vehicle, OBD2 cables, antennas, cellular connectivity, wireless sensors, software, and testing. We can also customize all of the components that you've seen today, including features on the epConnected vehicle, enclosures, cabling, and wireless interfaces for Bluetooth, cellular, near field, and GPS. We can also do wired interfaces for RS-232 Modbus and analog or digital I/O. We can perform wireless certification, and all of the software that we've shown today can be customized for the customer's application. Once this system is finalized, Embedded Planet can provide the complete kit as a production solution. During production, we can provide test logs for each serialized system, which includes system test, cellular connectivity, certificates for cloud connectivity, and custom software installation. Embedded Planet can combine the products and software you've seen today into a complete solution, so you can focus on helping customers manage their fleets or manage your own fleet. Thank you, and John, on to you.
Thank you, Matt. Go ahead and next slide. So what Matt, Steve, and also Nathan mentioned is a lot about sensors and getting that data up into the cloud so the data can be useful. And I just want to make a point here that sensors are really the foundation of IoT systems, and it can be sensors that are, you know, discrete individual sensors that are added on later, or they could be embedded into the whole system. But sensors are really a key portion of IoT systems. If you look at TE Sensor Organization, we're about a $600 million organization focused on industrial, medical, and automotive space. And in that, one thing that's really important is that most of our business, over 80%, is in what we call harsh environments. So we are experts in really building sensors that will last in the environment that they're supposed to last in for a long time. And that is really quite critical. Like if you're on a truck, or on some of the applications, I think you mentioned you had the water hose for doing chemicals on lawns. I'm sure they're running into mud, rain, sleet, snow, all that kind of fun stuff. So you got to have stuff that's going to last in there year after year after year. And that's what TE is really good at, is developing sensors for harsh environments. So go to the next slide, please. And if you look at TE sensors, I mean, we have what we call an unmatched portfolio of sensors. So we have everything from humidity, we have pressure, we have temperature, vibration, position, force, and photonics. And in these technology areas, we are an end-to-end provider of it. So we have our own MEMS fabs, we make our own piezo film, we basically do the second level packaging and integration. And so during all the many years we've been doing this at TE Sensors, you know, we are really good at working very closely with customers, you know, to solve their problems. And, you know, that's across pretty much any of these sensor technologies. The next slide, please. And here's just an example. So you mentioned, Matt mentioned this a couple of times, our 5600 family of sensors. This is a BLE4 sensor. It has what we're called, it has an advertising mode as well as a pairing mode. So you can go either way depending on what kind of power you're looking at, or you need lifetime in the battery. 24 bits in pressure resolution. It goes from 30 PSI up to 10,000 PSIs, and actually we can go a little higher if you want to, but you know, it's spec'd at 30 to 10K PSI. It uses a CR2050 coin cell battery. It's in an IP67 rated, so it has been rated at IP67, and it actually has hazardous location ratings for class 1, div 1, and then also ATEX zone 0. So, you know, this is a really great product to go out there and put into environments. And what we're seeing is why are people using this? It's really the whole idea of wires. You don't have to put wires in there. Even if you think on a piece of equipment or any type of mobile equipment, you'd say, oh, there's plenty of room. You can run wires around. But when you start working around the equipment, the wires get corroded, they get broken, they get it's amazing what happens to stuff like that when they get out there. So having no wires makes a huge difference there. And it also is a lower cost. I mean, instead of having to have somebody climb all over the machine and run stuff, you can actually just screw them in and you basically go. And the applications we see, you know, just like Matt showed, is really around monitoring either hydraulics, pneumatic systems, and pressures, tank levels, things like that for these type of sensors. So go on to the next slide, please. And this is a cool product that is actually CAN bus out. So it has OPS3 outputs on it. And it's really for oil quality. We call it a fluid property, but it's really around the quality of the fluid. So it has dynamic viscosity, density, resistance, dielectric constant, and temperature. All of those outputs are available in this one sensor. So that data goes up into your analytics, and you can actually start, you know, compiling data around when that oil is getting you know, starting to fail. It's really great for places where you have, you know, you're out in real dusty environments or dirty environments, because, you know, you don't have to rely on, okay, you change the oil every X number of hours, because sometimes you can get some dust or something inside the oil and it'll start causing your machine to degrade. So what this does is it'll do real time. It'll let you either extend the life of the oil if it's still good over than what's just the standard time based, or if you start getting some particles or things in your oil, it'll start detecting that so you can change it before it actually damages your system beforehand. So this is a pretty cool product that we have, you know, specifically for the ICT market. Next slide, please. And that's it. And I'll hand it over to Bianca.
Thank you, John, and thank you everyone for attending today. I'd like to thank our speakers for joining us today and for everyone on this call for joining. We hope that this presentation was insightful for you. And if you have any questions, please visit us at the websites presented to you on the screen, and we will be happy to help you. We would like to thank you for your time and wish you a great rest of the day. Thank you and take care.